Hey everybody, in this video we are going to write the equation of the piecewise function you see on your screen over here. So bit by bit what we need to do is analyze which function is modeling each situation, and then we will write out the three pieces as transformations of parent functions, and that was one of our recent topics. So let's get started over here. So first thing I'm going to do is I'm going to draw out my cute little curly bracket over here. And then I'm going to go from left to right. I'm going to start with the little peach looking graph, that orangey colored one. So what do we got over there? That, to me, what I'm seeing, a lot of you guys mix up cube root and cubic. So the cubic third power, it grows very fast. It gets very, very big. Something to the third power is something times itself 3 times. It's very steep. That's x cubed. So just think x cubed, the little exponent goes up in that little corner. It's going up, 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 and away, right? Versus the, versus the cube root, which is going to look more like that. It's going sideways. It grows much slower. It's kind of like a square root, but it's got a cube root. But it's like bleh, a little flat going that way. So don't mix those up. It's kind of ridiculous to mix them up. I'm not going to lie. Okay, not a good look. It shows that you have you're struggling with number sense. Like you're not understanding what raising something to a third power does versus finding the cube root of something. So definitely not a good look to not know the difference between those. So you gotta figure it out, okay? Just saying. So this is going to be a cube root, okay? And I'm going to set that up right there. It does not look like there's any vertical stretches or compressions. I see up 1 and out 1. That looks pretty standard to me, and that's all I see. Now, is it possible this is something different? Sure. But based on the information given, that's the most logical thing it should be. So I'm actually writing a little bit too large. So let's go over here and like squeeze it a little bit more. So we're going to shift left 4 units because I'm modeling it off of this spot here. That would be the transformed origin point, you know? So if I went left 4 in this backward house, you will have x plus 4. And then it went up 2, and that's pretty normal right there, comma. Now, when do I want this graph? From left to right. From left, negative infinity until negative 3, and that's colored in, so we use a bracket, and that's it. So far, so good. Next up, we have this green, lime green looking piece right here. Now, that over there looks to me like something linear. Now, if I don't know what everyone is so obsessed with y equals mx plus b form for. It's stupid. Not that it's stupid, but it's so silly. It's like not necessary. There are other forms of lines, like the ones that we talked about when we transform functions. If you try to write this as y equals mx plus b, your b or your y-intercept is a gross number. I don't feel like figuring it out or thinking that hard. Just use one of the 2 endpoints, right? And here we already have a graph. I mean, I could even figure out the slope this way. Slope is rise over run. So I'm going to start here, right? Rise up 2 over, run is the left, right? So 1, 2, 3, 4, 5. So my slope is 2/5. It's rising from the left to right, so it's positive. It's positive 2/5. Okay. So what do I got? I have. That's not the pen I want. Sorry. 2/5. Now I'm going to do parentheses. It's to the first power because it's linear, and I could pick either point. I could pick the one down there in quadrant 3 or the one up in quadrant 1. Okay. So let's say I do the one over here. Okay, in quadrant 3, I'm going to work on that one. So that means I have x plus 3, and on the side, minus 1, comma. So when do I have this? So that's perfectly fine. I promise if you distribute the 2/5, combine like terms, you'll get the y-intercept, but it's great the way it is. When do I have this? I have this with parenthesis from negative 3, comma, 2 with a bracket. Done. And if you had done the other one, instead of plus 3 over there, you would have minus 2 in that spot. And instead of minus 1 right there, you would have plus 1 right there. And that would be using that spot, okay? But I chose to use I don't mean to be hitting those things, sorry. I chose to use the other point in quadrant 3 right there. And then next up, the last piece over here, all the way on the far right side. This guy over there, it's like macaroni and cheese or something. So let's see what function looks like it's modeling this. And what looks like we went up once. It looks like we went up 3. 1, 3, 5, 7, classic. That is the parabola pattern, right? So we have x. I don't like this pen. I think the crayon pen is cuter. I don't know if you have an opinion, but I certainly do. Okay, x, what is that? To the right 2, minus 2 squared, right? Backward house. And then it looks like we went down 3. No stretches or compressions. And that looks like it picks up at 2 with a parenthesis, and it keeps going right toward infinity. And there you have it. That is the end of this example. So questions, comments, concerns, feedback, requests, you could go ahead and put that in the comment section. At the end of this video, there will be a link to the playlist. There were about 9 videos on there already, and I started adding a few more. I think that the newest videos will go to the bottom. And also in the description box of this video are going to be, if you scroll down, long division examples, because I know some people were requesting some help with long division. I did share it, but it's also in the description box of this video for finding those slant or certain oblique asymptotes of rational functions. So if you need help with long division, there's a bunch of lesson videos or example videos in the description box below. So that's it. If you're happy you know it, thumbs it up. Not so much, thumbs it down, and find another video that you need to help you figure out what you're doing. All right, bye for now. Adios.